Let's jump right into this explainer on NCP-MCI 7.5 to 11.1 PCBR, the only supported PCBR method. If you're an infrastructure admin gearing up to pass the Nutanix NCP-MCI 7.5 certification, you are in exactly the right place. Today, we're zooming in on a highly specific, very testable topic from section 11.1, which is all about Prism Central Backup and Restore. Understanding the strict, unbending rules around backing up your Prism Central environment isn't just a casual best practice for your day job, it's absolutely mandatory if you want to pass this exam. We're going to cover this thoroughly at a steady pace so you're totally armed and ready for whatever scenario questions they throw at you.
Here is our roadmap for this explainer. First, why PCBR matters. Second, a walkthrough and the why behind it all. Third, exam traps and edge cases. And lastly, the key facts to memorize.
Let's start with Section 1, why PCBR matters, building the baseline for Nutanix environments.
Let's make sure we're all speaking the exact same language before we dive into the deep end. When we say PC, we mean Prism Central, right? That's your overarching multi-cluster manager. PE stands for Prism Element, which is the localized cluster manager handling the individual nodes. PCBR is Prism Central Backup and Restore. That's the automated built-in solution designed specifically by Nutanix to protect and migrate your PC instances. And of course, VM stands for Virtual Machine. Having these definitions locked in as an immediate reflex is basically step 1 for the NCP-MCI 7.5. Now, there is a very definitive line drawn in the sand here, and it's vital for both your exam and your production environment. On the test, you are almost certainly going to be presented with scenarios where some hypothetical admin tries to back up a Prism Central VM using third-party enterprise backup software, or maybe they attempt to use standard Nutanix async disaster recovery snapshots. You have to remember this golden rule. PCBR is the only officially supported method to back up Prism Central. Period. End of story. Relying on protection domain-based disaster recovery, protection policy-based workflows, or external third-party tools renders those Prism Central instances completely and totally unrecoverable.
Moving on to Section 2, Walkthrough and the Why. The mechanics of backups and managed cluster state.
So we know what is supported, but as admins, to really master this material, you need to understand exactly why the alternatives fail. There's a direct quote from Nutanix Knowledge Base Article 9850 that highlights the fundamental problem perfectly. Basically, taking a standard traditional snapshot of a Prism Central VM just doesn't capture and maintain all the complex state information about the managed clusters. When an admin mistakenly restores from an unsupported standard snapshot, they are instantly introducing a catastrophic state inconsistency between the overarching Prism Central manager and the local Prism Element clusters.
Think of it like this. Prism Central and Prism Element are in a constant, highly active conversation. They're always talking, exchanging heartbeat data, keeping their distributed databases perfectly in sync so they can manage your VMs. If you aggressively roll back Prism Central using a traditional VM snapshot, Prism Element has already moved forward in time, but Prism Central is suddenly stuck in the past. It's basically suffering from amnesia. Their database states clash violently, and the result? You immediately lose manageability of your VMs across the whole environment. You might see random reboots, severe service crashes, just a complete breakdown of cross-cluster orchestration. This is the exact technical reason why the official Nutanix architecture strictly mandates PCBR to maintain that delicate PC-to-P consistency.
Understanding that state consistency is literally everything here, let's look at the core capabilities of PCBR. It is fundamentally way more than just a simple backup tool. PCBR natively handles 3 distinct and crucial operations. First, backup, to safely copy your data. Second, restore, to replace older or corrupted instances. And third, migration. This is what safely moves active Prism Central instances from one physical cluster to another without breaking that critical database consistency we just talked about.
Now, comparing the backup options is super important, as you'll definitely face these 2 distinct architectures on the exam. Example 1 is continuous backup. This is your real-time protection targeting up to 3 registered AHV or ESXi local clusters. It gives you a highly aggressive recovery point objective, or RPO, meaning the maximum amount of data you can afford to lose of just 30 minutes. Example 2 is point-in-time backup. This targets a single object storage bucket like AWS S3 or Nutanix objects. Your RPO in this scenario is much wider, and you can configure it anywhere from 1 to 24 hours. But you really need to note the recovery time objective, or RTO, which dictates how long it takes to actually get the system back up and running. It is exactly 90 minutes for both methods. Just keep in mind, for maximum resilience, a hybrid setup combining both continuous local backups and point-in-time remote object backups is highly recommended.
All right, Section 3, Exam Traps and Edge Cases. Let's look at how the test tries to trick you. Let's shift gears and tackle the exact edge cases the exam writers love to throw at you. Here's a classic exam trap scenario. Imagine a multiple-choice question that asks, an administrator decides to use VMware vMotion to migrate a live Prism Central VM to a completely new cluster to balance compute resources. What is the expected outcome of this action?
The answer you have to select is that this action leaves the entire system in an unsupported state. Live migrating Prism Central instances using vMotion is strictly forbidden by Nutanix. The underlying database mechanisms just aren't designed to survive that type of hypervisor-level stun and move. If you ever need to move a PC instance to another Nutanix cluster, you absolutely must leverage PCBR's built-in migration capability. PCBR gracefully handles the orchestration, making sure all those important service configurations and database states safely transition over to the remote cluster without breaking your management plane.
You also need to dodge these other critical edge cases that frequently pop up as multiple-choice distractors. First, if you're operating a smaller backup cluster with fewer than 3 nodes, the system physically cannot automatically recover Prism Central Key Management Server, or PCKMS secret keys. In that scenario, you have to manually back up those encryption keys before you perform PCBR. Second, if you initiate a Prism Central software upgrade, do not panic if your PCBR backups suddenly stop. PCBR is explicitly designed to pause automatically during an upgrade to protect the integrity of the database during schema changes. It will safely resume on its own when the upgrade finishes.
Let's think about what happens under the hood when a restore actually completes. Once the system shows the recovery task has hit 100%, you enter a mandatory, non-negotiable 10-minute stabilization window. Do not try to log in. Do not hit the system with automated API calls. Why? Because the underlying microservices infrastructure is incredibly busy rotating internal security certificates and aggressively restarting core services like identity and access management. If you get impatient and try to run an API script during this window, there's a really good chance you'll lock out your own admin credentials and create a massive headache for yourself.
Finally, Section 4, Key Facts to Memorize. This is your high-yield retention for the NCP-MCI 7.5.
30, as in 30 minutes. This is your strict recovery point objective, or RPO, when you're using continuous backups targeted to local AHV or ESXi clusters. In real terms, this means that in the absolute worst-case scenario of a complete failure, your maximum potential management data loss window is restricted to just half an hour. 90. That's 90 minutes. This is your standardized recovery time objective, or RTO. It absolutely does not matter if you're restoring from a fast, continuous backup on a local cluster network or pulling a point-in-time backup down from a remote AWS S3 bucket over the WAN. The officially expected and tested time to full recovery is 90 minutes across the board.
10, meaning 10 minutes. This is the exact mandatory wait time required for the Prism Central instance to stabilize post-restore. Remember, that microservices infrastructure is busy rotating certificates behind the scenes. Keep your hands completely off the keyboard and do not run a single API script for 10 full minutes after the system tells you the restore is complete.
Take a mental screenshot of this final checklist right now. If you can memorize that PCBR is the singular supported method, that traditional snapshots fundamentally destroy PC to PE state consistency, that continuous backups target up to 3 local clusters while point-in-time targets a single remote object store, and that vMotion is strictly forbidden for migrating PC VMs, well, you're going to successfully navigate almost any tricky scenario question they throw at you on this topic. So, I'll leave you with this. Knowing the catastrophic risks of state inconsistency, how will you audit and adjust your own infrastructure's Prism Central protection strategy today? If you had a total cluster failure tomorrow morning, are you absolutely certain your Prism Central backups are fully supported by Nutanix, or are you sitting on a ticking time bomb of unsupported snapshots? Think about it. Go audit your environments, lock these mechanics down, and you'll be well on your way to mastering the NCP-MCI 7.5.